Okay, this is quiz number 26. This one is, I guess I didn't really talk about what a transfer function is, but if you think of this as an input-output relationship, okay, so if I were to write the output voltage V out, and this is going to be in the phasor domain, that is going to be I could actually write this as some function times V in. And this will be, so these are all phasors. This is phasor, and this will be something in the phasor domain, but it'll be a function of frequency. Since, we're assuming here that there's a frequency, we're going to have, or that Vn is, what we're assuming is that little Vn is some, capital V cosine of omega t, like that. And this omega, is going to be inside of the impedance here and the impedance there. And so this function here is going to actually be a function of omega. In fact, it'll be a function of j omega. I'm actually not going to ask a question like this on the exam, but this is a good exercise. So this function here, we're going to call hj omega, and it is the transfer function. Okay, so the thing that I will ask is something about op amps. So this is a good way to understand what's happening with an op amp. So again, if we were to convert this circuit, we're going to convert into phasor domain, and then we're just going to find V out as a function of V in, and the stuff in between is the transfer function. Okay, so how would we do it? The first thing is to convert everything to phasor domain. So when I convert this to phasor domain, I'm going to go like this. I'm going to have V in, okay, and then it goes through a capacitor and a resistor. So the capacitor will have, I'm going to just write it as 1 over j omega c instead of minus j over omega c. And then I'm going to just call this R. And then I go into my, this is in negative positive. And the thing to notice here is that, so this is going to be j omega L. And the thing to notice is that we're in a negative feedback configuration, right? So this voltage gets fed back into the negative terminal. So we're in a negative feedback configuration. And then if we look at this voltage, that's going to be V out. All right, so, and let me just say, the reason why we don't kind of pull all these together is because there's actually more going on here, right? So like there's a voltage here, and the current that actually would flow, would actually come from this guy. So it wouldn't actually come from this thing. So we're just going to say, well, okay, these are all hooked to ground, and current is going to, the current that kind of flows here, they don't kind of close back on each other. So it's a little more complicated than that because of the presence of this op amp, which is hooked to its own battery supply. Okay, so we'll just say, well, okay, these are all at the same voltage, and we'll worry about closing when we draw something back here, that means the current's going in that direction. These may have different currents. Okay, so the one thing we know is when this is in feedback configuration, that these two voltages are the same. And then with an op amp, we always know the current here are 0. Okay, so this voltage then, since this voltage is 0 volts, this is going to be 0 volts. Okay, so we know the current, well, I guess we come down here. This is 0 volts. This is 0 volts. Okay, so the current in phasor domain, let's call this I1. Okay, I1 is going to be this voltage minus that voltage divided by the impedance in between. So in other words, I can write I1 is going to be V in minus 0, okay, divided by, divided by the the impedance. So it's going to be R plus 1 over j omega c. Okay, so that's that expression. And then this current, let's call this current I2. It's going to be this voltage minus that voltage divided by the impedance in between. So we're going to have I2 is going to be V out divided by minus 0 divided by j omega L. And then since there is no current that flows in here, this current, that current has to be minus that current. So in other words, I2, we know then that I2 has to equal minus I1. Okay, so we hook those together, and we're going to have I2 is going to be V out divided by j omega L, and that has to equal negative V1, which is going to be minus V in divided by R plus 1 over j omega c. Okay, and that is true if V out is going to be equal to, so now I'm going to multiply both sides by j omega L minus j omega L divided by R plus 1 over j omega c times V in. And now I'm just going to simplify this a little bit by multiplying the top and the bottom by j omega c. And so this is going to be equal to, so in other words, I'm going to multiply the top by j omega c and the bottom by j omega c. So that is going to be, when I multiply the j omega c through on the bottom, this becomes 1, and then I get j omega c r. So I'm going to have on the bottom 1 plus j omega c r, and I have v in here. And then when I multiply here, I'm going to have j times this j gives me a minus 1 times a minus gives me a plus 1. And then here I'll have omega squared LC. So this will be omega squared LC. Okay, so this guy is called the transfer function, H. And since it's a function, I really, so up here we wrote j omega. This is sort of standard notation, H of j omega. If we wanted to write it as thinking of the input variable as omega, this is hj omega. You don't have a j omega here, so we could write h of j omega being the we would have what? Minus j omega squared LC over 1 plus j omega LC. Another way to think about it is you could write, the typical way to write this is also, say, h of s is going to be equal to minus s squared LC over 1 plus s LC. And then we let, where s equals j omega, like that. Anyways, again, this is called the transfer function. Or more commonly, this is called the transfer function. And for this particular circuit, that would be the transfer function. Again, if this is confusing to you, the main thing I want you to learn here is how the op-amp kind of affects this circuit. And the op-amp can actually, we can work with general impedances. The whole thing of a transfer function confuses you. That's okay. We'll wait for other classes. I'm not going to ask any questions on it.